Hey everybody, what's up? Another day in paradise here at Clark High School, right? In this video we're going to be looking at matrix multiplication. And rather than go through a PowerPoint and talk about this and that and then do examples, let's just dive right into examples. Our first type of multiplication is where we're taking a matrix and we're multiplying it by a number. And intuitively, you're probably thinking to yourself, I know exactly how to do that. I'm going to take the 3 that's on the outside of my matrix and I'm just going to multiply it by everything inside the matrix. And you would be right on target. That is exactly how we do this type of multiplication. For this first example, I'm going to write things out in painstaking detail. But if I were really doing this problem, I would just go straight to doing the multiplication. I would say, oh, 3 times negative 3, that's negative 9. 3 times negative 3, that's negative 9. 3 times 6, that's 18, right? 3 times negative 2, how much is that? Negative 6, right? 3 times negative 3, that would be negative 9. And then 3 times negative 2, that would be negative 6. All right? So exactly what your intuition is telling you to do, it's good to follow that in this case. We just multiply everything in the matrix by the number on the outside, and this is the resulting matrix. Negative 9, negative 9. 3 times 6, 18. 3 times negative 2, negative 6. 3 times negative 3, negative 9. 3 times negative 2, negative 6. There's our final answer. So when we scale the matrix that we were given by a factor of 3, the resulting matrix is this guy right here. Now, quick sidebar. This type of multiplication has a fancy name. You don't need to know this to do the math, but it's still good to know these terms. The name of this type of multiplication, when you're multiplying a matrix by a number, is called scalar multiplication. All right, next example is for you. Pause the video, try it out. Okay, check it out. The answer that I got. First column, 24, negative 12, negative 16. Second column, negative 20, negative 20, 12. I hope you got the same thing. If you're wondering how or why I got what I got, I've shown the work kind of as a sidebar. If you're still puzzled, call me over to your desk. I'll be glad to help you. But the main reason is we're just taking every number inside the matrix and we're multiplying it by the number on the outside. Next example coming your way. And this one we're going to do together because it's something shiny and new. What's happening here? In this example, we want to multiply two matrices together. Very interesting. Can we even do this multiplication? Can you multiply two matrices? The answer is yes, but it depends. Think back to when we were adding or subtracting matrices. In order to add or subtract matrices, what condition had to be met? The matrices had to be the same size. With multiplication, a little bit different, but somewhat similar. Right, and that's kind of contradictory, right? So let me explain. Here's how you determine if you can multiply two matrices together. Start by listing the size of each matrix. On the left of the dot, multiplication dot, we have this matrix, and its size is 2 rows by 3 columns. In the second matrix, we have 3 rows by 2 columns, 1, 2. If these matrices can be multiplied together, the numbers sandwiched in the middle must be the same. And they are in this case. So that's kind of bad news for us. We got a match.com. And I'm putting the smiley face kind of tongue-in-cheek because it's really somewhat bad news, because that means we can actually multiply these matrices together and get a new matrix. If these two numbers did not match, we would say UND and move on. But since they match, now we have to multiply them out, so let's do that. This is where things can get a little messy and maybe even a little confusing, because you're going to see that we're going to be swimming in a sea of numbers, and that's what makes this somewhat challenging. But with practice and perseverance, you'll become a pro. Here's how we're going to multiply things. I'm going to highlight my first row in the first matrix. I'm going to highlight my first column in the second matrix. And we're going to multiply elements position-wise, and then we're going to add them together. That sounds really weird. Like, what did he just say? He might as well be speaking Greek. Here's what I mean. What's first in line in the first matrix? It's 5. What's next in line? What's first in line in the second matrix? It's 6. Plus, what's next in line in the first matrix? It's 2. Times, what's next in line in the second matrix? -3. Plus, what's next in line in the first matrix? -6. What's next in line in the second matrix? 0. Now notice that, how did I know to write these numbers in the first row, first column of the new matrix? What row am I in the first matrix? I'm in the first row. What column am I in the second matrix? I'm in the first column. First row, first column means I should be writing my stuff in the first row, first column. Now, we still have second matrix. We can't play favorites. We can't handle the first column by multiplying by the first row of the first matrix, but then leave out the second column. That's not fair. So let's highlight the second column and repeat the process we just did with the first column. First in line times first in line. 5 times 6. Then I'm going to tack on to that by adding what's next in line. 2 times next in line, -1. Plus, next in line, -6 times next in line, another -6. This is going to be somewhat squashed. I'm sorry about that. All right. We'll worry about multiplying and adding specifically as soon as we finish writing everything out first. And I recommend you do that also. Let's write stuff out first and then worry about crunching numbers on the calculator. What's next in line? Well, I used the first row, but don't I have some other rows in the first matrix? I have another row that I could repeat this process with both columns in the second matrix. So let's do that. I am in the second row, first column on the left of my equal sign. Second row, first column. That means when I'm writing this stuff and junk out, I should be in that same position in my new matrix. So let's do this. Second row, first column. Here we go. 2 times 6. Plus, what's next in line? 1 times -3. Plus 1 times 0. Finished, right? We've exhausted all of the numbers in the second row in the first column, but I also have another column in that second matrix that I can repeat this process with. So let's do it. Now, just to reiterate, what row am I in the first matrix? I'm in the second row. What column am I in the second matrix? I'm in column 2, the second column. That means when I'm writing this stuff and junk out, I should be in the second row, second column of my new matrix. So let's do it. It's the first times the first, 2 times 6, plus the next times the next, second, which is 1, times the second, which is -1. Plus 1 times -6, right? Get this out of the way. All right, so here's what I would like you to do right now. Pause the video, crunch these numbers, and let's see if we get the same answer. Let's do it. All right, check it out. In the first column, I got 24 and 9. In the second column, I got 64 and 5. I hope you got the same thing. If you didn't, call me over. I'll be happy to look over what you did and see if I can pinpoint where we sort of went off the track. All right. Next example, let's see what shakes loose. Here's what I'd like you to do on this example. Pause the video, try it out, and then see if your answer matches what I got. All right, check it out. The answer that I got was -18, -6 in my first column, 6, 2 in the second column, -1, 8 in the third column. Now, if you didn't get that and you're not sure where you made a mistake, call me over. I'll be happy to assist you and clarify. Now, I want to point something out really quick before we do our last couple of examples together. What size matrix did we end up with? What size matrix did we end up with? 2 by 3, right? I want to show you something. This is just kind of nice to know. We could have already predicted what size matrix we should end up with when we first determined that we had a match and we could multiply these out. Check out the numbers that are on the end. 2 and 3. What kind of matrix did we get? What size? I mean, 2 by 3. See? So if you have a match with the middle two numbers, the numbers on the back end and the front end will tell you what size matrix you should end up with. We should have 2 rows and 3 columns, which we did. That makes sense. All right, next example is for you. Have a go with it. Here we go. Oh, this is non-bene. It's no match. That means this multiplication can't be done. That means we write undefined and we move on with our lives, right? See, this matrix has 2 columns. This matrix has 3 rows. No match means you can't do the multiplication. All right, one more example coming your way. I'd like you to work it out and then check your answer. Let's do this. Oh my God, wait! Mistake! I accidentally wrote 3 times -6. I'm sorry about that. My bad. It's -3 times -6. And I apologize for that mistake. So the answer that I got, though, when I did multiply this stuff out correctly and had everything written correctly, I got -9, 3, -13, -13. All right, that concludes this video, and I hope you've gained something from it, and keep up the great work. Bye-bye.